Okay, this section is going to cover 4-4, and we're going to be adding fractions in this section. And in this section, we're going to be adding like fractions, just like we did with like terms in our previous sections. For an example, 3x plus 5x, they both had the variable x, so we could add those up, and our final answer was 8x. Well, the same thing applies to fractions. If it has the same denominator, then it's a like fraction. So I'm just going to rewrite that as 1 plus 5 all over 12. Now I'm going to add it. So when I add that, you end up with 6 over 12, and I can see that's not in lowest terms, so I'm going to factor out. I can get a 6 times 2 out of the 12. So let me rewrite that as 6 on the top, 6 on the top, and on the bottom I'm going to write 6 times 12, 6 times 2 to represent the 12. And we can see the 6's will divide out. So our final answer here is 1 over 2. So 1/2 is the final answer. So that was number 1. Let's go ahead and work on number 2. So number 2 is -7 over 20. And we're going to add that to 2 over 20. So since we're adding, the first thing we have to ask ourselves, and we don't ask this question when we are multiplying or dividing fractions. This is only when we're adding or subtracting. So the first thing I ask myself, does this have the same denominator? It does. So they're like fractions, so I can go ahead and add those up. So I have -7 plus 2 all over 20. So remember, the rule states when the signs are different, you subtract and take the sign of the larger number. So we have -5 over 20. I know that's not in simplest terms because I know 4 times 5 is 20. We can get those 5's to divide out. So that would be -5 over 4 times 5 to represent the 20. And we know this divides out to 1. So our final answer here is -1 over 5. So -1/5 is our final answer. All right, let's try number 3. So number 3 is -7 over 20 added to, and we're using parentheses just to protect the negative sign, -9 over 20. First question, okay, we're adding fractions, so is the denominator the same? They are, so we can go ahead and add those up. So I'm just going to rewrite it as -7 plus -9 all over 20. They're both the same sign, so we add them and keep the sign. So the answer would be a -16 over 20. That's not in simplest terms because we can pull out a 4 from each one of those. So we rewrite -4 times 4 is 16. And we know 4 times 5 is 20. So we can see those divide out to 1. So our final answer for this would be a -4 over 5. And now that's in simplest terms. Let's try number 4. So number 4 is -8 over 18 added to 2x over 18 plus 3x over 18. So we can see we're adding fractions. So we got to ask the question, are the denominators the same? All 3 of them are. So let's just go ahead and rewrite it. So I'm going to rewrite it as 8x plus 2x plus 3x all over 18. Now, I start looking at these. I'm like, okay. So these are all like terms. I can go ahead and add all of those because they all have the variable x to the first power. Remember, when the 1 is eliminated, well, when there is no exponent, we understand that it's x to the first power. So they're all the same. So I'm going to just add up the 3 and the 2 first, just to keep it simple. So that would be -8x plus 5x all over 18. Now the rule states opposite signs. You want to subtract, take the sign of the larger number, which is -3x over 18. That's not in lowest terms because I know 3 times 6 is 18, and we can get the 3's to reduce. So I'm going to rewrite it as -3x over 3 times 6 to represent the 18. We know that divides out to 1. So our final answer would be -x over 6. Because remember, 1 times x is just x. And that is our final answer. When you're working on this stuff, don't forget to keep carrying that negative sign with you to your final answer. All right, so let's move on to number 5. Number 5 is pretty simple. It's just 9 over 20 subtracted by 1 over 20. So even though it's a subtraction problem now, it doesn't matter. The same rule applies. Are they like fractions? And the denominator is the same. So I'm just going to rewrite that as 9 minus 1 over 20. And when you subtract, you end up with 10 over 20, which we know that's not in lowest terms. So I'm going to factor out the 10 down below. So 10 over and then 10 times 2 is 20. So we know that divides out to 1. So our final answer here is 1/2. So you can see with subtraction problems, as long as the denominators are the same, we're going to apply the same rule. So let's go ahead and try number 6. So number 6, if we have 2 over m subtracted by 3 over m. Now, even though it's a letter, they both are exactly the same. So they are like fractions. So I'm just going to rewrite that. And when I rewrite it, I'm going to rewrite it as 2 minus 3 all over m, the same denominator. Now, remember the rule states when it's subtraction like that, we rewrite it as an addition and make this sign the opposite. And then we apply our addition rule. And we know that we subtract, take the sign of the larger number. So our answer here is -1 over m. All right, let's try number 7. So number 7 is -20 over 21. And we subtract it by, and then here's a parentheses just to protect the negative sign, -1 over 21. So we see it's a subtraction problem of fractions. The first thing we ask, are the denominators the same? If they are, I'm just going to rewrite it as -20 minus and then -1 all over 21. So I'm going to go off to the side, the -20 minus my -1, and I'm going to change that minus to a plus and then make sure this is the opposite, which will make it a +1. Now we apply the rule. Signs are opposite, subtract, take the sign of the larger number. So that would be a -19 over 21. And you can't reduce that down any further. All right, so let's move on to number 8. All right, so number 8, we have 3 over 20 minus 11 over 20 minus, 22 over 20. First thing we look at, we're a subtraction problem with fractions. So I got to look, are the denominators all the same? They are. So I'm just going to rewrite that as 3 minus 11 minus 22 all over 20. And I'm only going to take 2 at a time up here. So I'm just going to take those 2. So 3 minus 11, which becomes 3 plus -11. And then we subtract and take the sign of the larger number. So it's -8. So that's the first part. So that would be -8 minus 22 over 20. Now I'm going to deal with a -8 minus 22. Remember, this is you add it, make this sign the opposite. Now the signs are the same, so you're going to add and keep the sign. So that should be -30. So this here now is -30 over 20. You can see that's not in simplest form. We can factor out a 10. So that would be a -10 times 3 over 10 times 2. And this divides out to 1. So now the final answer here would be a -3 over 2. So hopefully you're catching on at this point. All right, let's do number 9. So number 9, we have 4x over 5. And that's subtracted by 3 over 5. Now this one's number 9. So this is one to remember. So the first thing you ask, okay, subtracting, the denominators are the same. So I'm just going to rewrite that as 4x minus 3 all over 5. And if you look, you cannot combine these two. You can't subtract them because the 3 does not have the variable x. So that is your final answer. So that was just a tricky one to see if you're recognizing that you could not combine anything further in that numerator. That is the final answer. All right, so I'm just going to toggle over to your homework assignments. So I just wanted to point out, when you do number 11, just remember your perimeter. What you're going to do with this one is you're going to add up all your fractions. So you're going to, and you can see they all have the same denominator. So you just add up 4 plus 11 plus 12. So, and the denominator will be 27, and just make sure it's in simplest form. And when you're adding up a perimeter, the perimeter will be the final answer in inches. Now this next one, number 12, if you notice there's only 2, but when you're adding a perimeter, you need to add up all sides. So for this one, you're going to duplicate the number. So it's going to be 1/10 plus 1/10. And then it's going to be 9/10 plus 9/10. So they just eliminated. Just know that these, when it comes to these squares, 2 sides are exactly the same in the top. So the left and right are the same measurement. They're both 1/10. And the top and the bottom are both 9/10. So you're going to have 4 fractions to add up. I don't know why they just eliminated to, just be a little tricky. So just know you're going to have 1/10 plus 1/10 plus 9/10 plus 9/10. Okay, so that one's been eliminated. So now number 14, we got to work with the lowest common denominator. So let me show you how to do that one. So this is what's going to lead us into the next section when we go into 4 or 5. Whenever you're looking for your lowest common denominator, so if I have 5, 6, and then I have 1/27. So the way this works, like 27, we say 27 times 1 is 27. 27 times 2 is 54. And I can already see the lowest common denominator is 54, because when you start working with the factors of 6, we know 9 times 6 equals 54. So that is the lowest common denominator. It's 54. And we're going to get into this more in the next section. We'll have more practice with that. So the last 2 problems in your homework, it's going to ask for an equivalent. So you're going to want equivalent. And this is another thing that's going to lead us into the next section, 4 or 5. So if it gives you something like 4, 7 equals, and then they have 35, and they're asking you what's equivalent. Well, how this works, you say to yourself, well, what times 7 equals 35? Well, 5 does. So 5 times 4 is 20. So you're finding something equivalent, because really anything 5 over 5, that just equals to 1. So you're not changing the value, you're just changing the appearance by multiplying it by the value of 1, which is 5 over 5. So, and in number 16, it just gives you a variable like this, 17x over 15, and then it gives you a 45. So the way to do this, to find out, you can just put 45 divided by 15 equals 3. So we know that 3 times 15 equals 45. So you do the same thing at the top. 3 times 17 is 51, and don't forget the x. That's the only difference between the two. And we'll go into this more into the next section.